Welcome to the course Digital Transformation and Technological Innovation. So, in the previous sessions we had already started our second module, that is digital infrastructure. So, let us connect again how digital infrastructure can support organizational information systems. So, let us pick up from the point where we stopped in the last session. So, we are talking about this particular question, that how to select secondary storage media and devices so that our organization's information systems are well supported. So, we talked about that there are the three important things that we need to look at. We need to look at the access method, the capacity and the portability. These three important factors go in a way in terms of deciding what kind of secondary storage would be suitable for our kind of organizational information systems need. So, then when it comes to access, we talked about that there is one thing is sequential access. So, which is a retrieval method that requires data to be accessed in its sorted order. So, that is one thing that we covered, and then the kind of technology that is there, one is magnetic tape and the tape cartridge. So, these are the main hardware that are available for which actually give this sequential access, which actually use the sequential access this kind of retrieval method. Now, how do they represent bits? So, represent bits using a small magnetized area, and so because of this they are slower access is there, but then they are less expensive, right. So, one organization and their top management in terms of CIO and CTO, they have to decide on it is less expensive, that means you can afford more of it, but then it is lower access. But another benefit that goes in favor of it is that extreme longevity. So, therefore, if you are looking to store certain data in secondary storage for a longer period of time and without any issues in terms of data loss and all, so you might prefer these two, magnetic tape and tape cartridge, this kind of secondary storage media. So, used for, therefore, naturally used for data backups and archiving, right, because extreme longevity is there, and despite slower access and despite the sequential. So, why slower access? Because sequential access is there, that means to be able to copy certain piece of data, you have to traverse through all the points in their order, right. So, that makes it slow. So, you cannot immediately jump to a particular point and copy that, right. You have to traverse through the stored order that is there, and that makes it sequential access, and that makes it slower, right. But extreme longevity, and therefore, data backups and archiving for these kind of purposes, this is quite useful. So, this was sequential access that we talked about in the last session, and now moving on to the second one, which is slightly faster, which is direct access. So, this is also a retrieval method that allows for the immediate retrieval of data. So, earlier one, sequential access, immediate retrieval is not possible, sequential retrieval is there, and that is why slower. Now, here immediate retrieval, so faster. So, we do not have to traverse the storage sequence, that we have to do in a sequential access, right. So, in the case of direct access, we do not have to traverse through the storage sequence. So, what is the example of storage media in this case? Hard disk drive, HDD, so which is essentially the magnetic disk. So, if you look at the technology is pretty much same. Here we talked about the magnetic tape and tape cartridge. So, the way bits are being represented using a small magnetized area, that remains same. So, here also bits would be represented using a small magnetized area, but now in this particular storage media, the magnetic disk, which is hard disk drive, HDD, the retrieval method is changed. So, it is direct access. So, therefore, it is faster, though the same kind of technology is being used, the underlying technology magnetic that remains same. So, bits being represented using small magnetized areas. So, slower access because the underlying technology remains same, but better than the magnetic tape or tape cartridge, less expensive because again the underlying technology remains same. So, therefore, less expensive, and therefore, that this is a benefit in a way if we are looking for backup and archival, those kind of thing. But typically when we talk about the HDD or hard disk drive, so it is typically used for mass storage and cloud drives. There are lots of cloud vendors, and they have to serve so many users, and they give so much of free storage to us also. For example, Google gives 15 GB in a free account. Similarly for OneDrive, similarly for Dropbox and many other cloud vendors. So they give us cloud drives free, the free account, the basic account also gives us free storage. So where that is coming from? So it is actually this less expensive HDDs these companies are investing in, these cloud vendors have invested in, and they are being used for mass storage, right? Because we do direct access, so that is there. Whenever we access our data on cloud drives, we are able to access any part of it, so the direct access is there. But then they cannot manage so many users which have subscribed into their cloud services for free. So therefore they go for this less expensive solution and they use it for the smart storage that is given as a cloud service. So this was about hard disk drive. Then moving on, the next one is that we are starting this session only is the solid state drive SSD, right. So underlying technology is memory chips. The previous HDD, the underlying technology was the magnetic disk. In this case solid state drive SSD, the underlying technology is memory chips. So memory chips we have already talked about in the sense that CPU and the memory itself, those two use the chip based technology, right. CPU for processing and memory for that is primary storage for storing. Now the kind of technology that we use in the primary storage, the same one we can also use for the secondary storage. So then it is referred to as solid state drive. That is the common product, hardware product that we have for secondary storage using the same technology, that is memory chips. So what are the benefits? Less power, right. This takes less power, right, and because you have to manage on off states, so therefore the amount of power that is needed to just manage that is less, right. Much faster access, right. Memory chips, this is much faster. So much faster than magnetic disk / tape / cartridge. So earlier secondary storage media that we talked about, magnetic disk, magnetic tape, or magnetic tape cartridge. So much faster than all these things, all these storage media. Less fragile. Why less fragile? Because there are fewer moving parts. So in case of HDD, there are certain moving parts that are part of that technology, the magnetic disk, and here in this case fewer moving parts, and therefore it is less fragile and therefore desirable. So less power, less fragile. So the two important points go in the favor of SSD. Then higher portability, right, than hard disk drive, because again less power, less fragile, so therefore portability goes up. So and we have less chance of damaging the hard disk when it is SSD in comparison to when it is HDD, right. But what goes against this one is the higher cost, right. This is higher cost and lower capacity, right. So that is why cloud vendors they go for HDD, because they have to provide the mass storage and free storage, right. But this is higher cost, this is faster but higher cost and lower capacity. Though production technologies continues to improve, so in future it might so happen that SSD also become quite cheaper because they become the preferred storage, secondary storage media, and therefore there would be economies of returns because of the scale, increase in scale, production scale, and therefore technology also improving. And so in future it might so happen that the cost might also go down, and therefore the solid state drive might become go to way, not just in more important scenarios, but even in the mass storage like clouds. And therefore when that happens, when that transition happens, you would also experience a slightly faster access to cloud drives, just because the underlying technology that is that got through the full transition from HDD to SSD. Now next one is so where SSD is being used. So boot drive, OS drive, because this faster access needed and you want to quickly boot, and or the OS drive where you would like to install your operating systems file and other important files, right, for faster execution of applications and other system software that are there, operating system software and utilities, services and application software, all that. So all that will be installed in the OS drive, and the boot drive, when we need to boot up the operating system. So that we talked about in the previous session. So boot and OS drive, we would like to store them in a SSD media. Personal, professional. So when we are using a computer, laptop or notebook for our personal or professional uses also, then also the faster access is preferred. So therefore in those cases also, so those computers, laptops, it is better, we would prefer the notebooks, the laptops which are having SSD. So you would also see that in the PC, laptop segment, notebook segment, you will see that it is the SSD that in most of the latest items in this segment, PC / laptop / notebook segment, most of the latest one are actually having the SSD option. So that is becoming the preference, because we want the faster access when we are working with our own personal computers and the applications, right. So higher end computing also, there also we might need faster access. You are working with the data, you are creating visualizations. So the interaction with the data is might be happening very frequently, and therefore in those use cases also you might want something that is faster. So in that scenario also, high end computing, for example AI applications or many other analytics applications, many such scenarios, there also we would like to have a faster access. Similarly for even in the transaction processing systems, we want our transactions to be quickly done, right. So all the payment systems, transaction processing system, there also we would like to do we would like to facilitate them faster. So therefore secondary storage also we would like to have SSD faster option. One of the most common product that is based on memory chips, that is falling under secondary storage media category is USB flash drive, right. This is also memory chips, very common. So if you have recently bought a USB drive, more likely it is going to be a USB flash drive, and more likely it is the underlying technology is going to be memory chips. So it is going to be faster. And in case you have an older pen drive, older USB drive or pen drive, that might be slightly slower because it might be having the older technology, that is magnetic, right. So these are the two examples under SSD. Now moving on, we talked about that the cloud vendors, how why they, for the mass storage and the free storage that they provide, they will go for the HDD, right, because it is low cost. So are there risks linked to that loss of data in the cloud, right, because HDD components, as we talked about, they have slightly more moving components than SSD, right. So the components can fail, and if they fail, therefore there can be loss of data. And because the cloud vendor, cloud drives and services, they mostly are using this for lower cost. So therefore there can be risk linked to loss of data in the cloud, right. Then what is the solution for this? And obviously cloud vendors have implemented many of these solutions. So we need to look at fault tolerant data storage devices, right, because a cloud vendor, they, in a way, there is a they are providing services, cloud drives or storage services, where this sort of guarantee is implicit that you will not be losing your data, right. Therefore they need to make sure that there is enough fault tolerance in their storage services. So fault tolerant data storage services is something that cloud vendors need to look at, and they are providing that. So when we say fault tolerant, what do we mean? So we should be able to continue with little or no loss if one or more key components fail, right. So if there is any failure, if we are using HDD, if there is any failure, then our data loss, that thing should not happen, right. So for that, what is the solution, what is the technology that is being used is the redundant array of independent disk, RAID technology. So RAID technology comes in as in a form, provides the solution in this case in terms of fault tolerant data storage services, redundant array of independent disk, RAID, right. So idea is to minimize the data loss in case the components fail because HDD. So let's talk about the RAID technology then. So RAID technology, it is applied to storage systems, right, to improve performance and data reliability. So again, to lower the risk of data loss So, that is the point about data reliability, and in that process may we improve performance as well. So, twin objectives is supported by the RAID technologies. Very common cloud vendors and big tech firms and other tech firms, for their own storage systems or the services that they are providing, it is very common that they apply the RAID technology to their storage systems. So, what it does, distributes data across multiple disks, using 3 primary techniques that we will talk about, right. So, this distribution is done across multiple disks, and what are the benefits, how it contributes to data reliability and how it contributes to the performance, that we will talk about. So, stripping and mirroring and parity, these are the 3 main techniques that are used in this technology, RAID technology. So, let us talk about each one of them one by one. Stripping, let us first take stripping. So, what happens in stripping under RAID technology? So, it splits data into chunks or blocks and spreads them across multiple drives, right. So, what is the benefit of this? When you split data into these chunks, so it boosts performance. Why? Because feasibility of simultaneous read or write to all disks comes in, because you are distributing chunks and you are spreading them over multiple drives. That means you can do simultaneous read or write to those multiple drives, so that parallel processing comes in, right, and because of that this boost in performance is experienced, right. So, boost performance due to the feasibility of simultaneous read or write to all disks, effectively multiplying the speed. So, this is stripping, if it is implemented in the RAID technology, then it will give the performance boost. And moving on, the next one is mirroring. So, what happens in mirroring? So, creates an exact copy or mirror of the data on 2 or more disks, right. So, because the idea was to also provide the data reliability, right. So, if you create an exact copy or mirror of the data on 2 or more disks, then in case one disk is there is some component fail, so there can be loss of the data, but because the copy or mirroring was done, so therefore you can get back the data. So, creates an exact copy mirror of the data on 2 or more disks, so thereby providing the data reliability, and that is the point mentioned here, that if one drive fails, the system immediately uses the other, right, and therefore high reliability and uptime, because some of these systems the cloud services and many apps which are essentially in a way we can say cloud apps, because they would be using data in from their data centers. So, the uptime is very important in this case. So, this particular point where keeping exact copy and something fails, so it will ensure the uptime also. So, high reliability and uptime. So, if we look at from the production point of view, from the service point of view, this uptime will also help here, and obviously providing the high reliability. Then moving on, the next is parity. So, in RAID technology, parity is another technique that is often used. So, what this is about? So, a mathematical calculation, right. So, often using XOR, right, used to rebuild data. So, in case there is a loss to the data, right, for some reason some component fails, and the exact copy was not there or only the partial copy was there. So, can we still get back the data, because there is a promise of that from the cloud service that there would be no loss, right. So, this parity helps in that case, mathematical calculation used to rebuild data if a drive fails. So, in case a drive fails, can we will we able to rebuild the data, so there is this mathematical procedure involving XOR is used. So, instead of keeping a full second copy, because keeping a full second copy for all data is going to be very expensive. Essentially, you are saying you would be doubling the storage that is needed, right. Instead of keeping a full second copy, which is very expensive for any organization including cloud vendors, of every file, the system stores just enough checksum info to mathematically reconstruct a missing piece. Some checksum is is stored, and that can be used to actually mathematically reproduce the data, mathematically rebuild data in case a drive fails. So, parity provides that fail safe options option for with the in the RAID technology. So, the three things we talked about in the RAID technology, right: stripping, mirroring and parity. So, parity, in case of we talked about, we want to rebuild the data, something failed, we want to rebuild, we did not have the exact copy. Mirroring, wherever we had the exact copy, we can directly use that, right, but it is not possible to have exact copy for everything. So, then we will fall back to parity. So, that scenario is covered, and then stripping is there, that gives the performance boost because we are distributing data across multiple disks, right. So, all three involves distribution. So, in stripping we say split data into chunks and then spread them, but even in mirroring, data is going to another disk. So, that is also in a way distribution of data happens, and parity also we would be able to rebuild. So, in a way that also gives a fail safe option. So, RAID technology is very commonly employed by the big tech and the cloud vendors all over the place. Now, moving on to the next one, direct attached storage. So, what is direct attached storage? So, this is simply the storage type where the drive is directly connected to a single computer server. So, essentially we are talking about a external hard drive, right. So, typically every computer will come up with the internal hard drive, which could be SDD or SDD depending on when you bought the computer. Now, as I said, most recent ones will be are likely to have SSD. So, so we are talking about external hard drive. So, that is being categorized here as a direct attached storage. This is considered simplest storage type. So, whenever you need extra storage for backup, mirroring, or for just extending the storage itself, right, then this is especially in the personal professional context, this is the go to option, having an external hard drive. Single user or computer is more likely the scenario in the personal professional context where we would end up using this. So, personal use, backup, these are the scenario, right. So, even in the organizations, many organizations will support this kind of purchase, so that their employees can have whatever important code or files or data, business documents that they might be working with, they can have quick access to that through external hard drive, because it gives portability option also, right. So, this is about direct attached storage, and then the next one is network attached storage. So, let us say you are working in a team and it is the same set of files that are being shared, same set of data that is being shared. So, you might benefit from a dedicated file level storage server, right. So, it is connected to a network, connects to a local area network, your own network within the organization or for your team. So, this storage is connected to your network where your computer is also workstation or notebook is also connected to, and this dedicated file level storage there. So, many members in the team, if they are collaborating on the same projects, engineering or non-engineering, technical or non-technical, they would be able to access files, right. So, shared network drive, essentially this is in a way. So, the direct attached storage, the example was external hard drive in a way, typical labeling, and in this case of network attached storage, which is NAS, the example is shared network drive. So, in a way this is shared network drive, multiple users computers would actually be accessing data or files from that storage. So, what it facilitates is facilitates collaborative work and file sharing, right, within the local area network, right. So, moving on, next one is storage area network or SAN, right. Now, this is slightly the expensive and high end option, only large organization would look to afford this. Storage area network SAN, a specialized dedicated high speed network, right. So, here the network is itself is a dedicated network. The earlier one in the NAS we talked about is a regular local area network where we are connecting our storage server to, right, and all other can access just like it is a using IP address, just like it is a in the network. But here a dedicated high speed network is involved in case of storage area network, specialized dedicated high speed network that provides block level storage to multiple servers, right. So, multiple servers would be connected and there would be a dedicated network. So, there will be very fast access to those servers, and the applications, whether the enterprise users or enterprise systems applications, they would need faster access to lots of servers lots of storage servers. So therefore, this will be more suitable option. This is like local network drive, right. So we are moving from external hard drive in DAS, direct attached storage, to shared network drive in network attached storage, to a local network drive. Why local? So it's a faster also. It looks like a computers will feel as if it's a local drive, but it's a local network drive. Dedicated network is there, so it's fast. So who would be using? And more likely enterprise user servers, because it's expensive storage setup. So enterprise user servers, and for what? For organizational work, enterprise application might be running on it, because many employees and other you might give access to some users and sometimes suppliers, partner also. We talked about that in the previous sessions. So this kind of use case this might be employed. Now we come to the cloud storage. So what happens in cloud storage? First one is personal. So in personal, what we typically use? Google Drive, Apple iCloud Plus, then OneDrive. So all these provide some free options, Google Drive 15 GB and all that. So what is the benefit of this kind of cloud storage? You get ecosystem integration. So if you are using Android applications and you are using Google Drive, so there would be more smoother integration, slightly faster access would be there. So for the benefit ecosystem integration, you would use this in a personal professional context. Similarly for iPhone, similarly for Windows. So these are the three typical options: Android, iPhone and Windows. And for the ecosystem integration and for your personal professional work, you would go for this kind of cloud storage. Then in case of enterprise, so in case of enterprise, you would you plan to run some enterprise applications, and for that you would like to have better access, faster access, more technological supports. AWS, Amazon S3, that is there. Then the Microsoft Azure is there. So these are the cloud options if the huge context is the enterprise. If we are into enterprise context, not personal professional context, then AWS, Microsoft Azure. So what you get? Massive scale, security compliance and app building and all that. So this is what if you are a non-tech firm and tech or some app or some information system is important part of your business, in the sense supporting your business activities, or the business activity is actually driven by some of these information systems, but you are not a out and out tech firm. So you would like to take advantage of some of these services from AWS, Azure, so that you get the scale, right, which supports your growth as a business growth, right, and you don't have to worry about security and all that. So this is there. Then hybrid SME, hybrid/SME, small to medium enterprises, or hybrid kind of environment. Then Dropbox business is another option. So what is the benefit of this particular provider? Ease of use for teams if you are collaborating, then ease of use, advanced file tracking and all this is there, faster access to files, so that is there. So these are the common options that we have in terms of cloud storage, personal, enterprise and hybrid. So let's stop at this point and we'll continue our discussion in the next session. Thank you.